In chapter 6.5, we're going to graph the square root and the cube root functions. So we're going to be looking at transformations of graphs, just like we did with quadratics and absolute values last semester. First one we're going to look at is the parent function for a square root graph. This is going to be the inverse of the function y equals x squared with the restricted domain of x is greater than or equal to 0. So it's going to be half of a parabola kind of laying on its side. So if we make a t-chart to graph this for my x values, I'm going to pick the x values that I know are perfect squares. So when I take the square root of them, I get whole numbers. So for x, I'm going to do 0, 1, 4, and 9. And to get the outputs, I'll just plug them in to my radical. So the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and square root of 9 is 3. So if you plot those four and connect them, you see how it's kind of half of a parabola. Here would be the other half, and it's laying on its side. The domain of the parent function of the square root graph is x is greater than or equal to 0. I cannot plug a negative number into a radical without getting an imaginary number, so that's why x has to be at positive values. And then if I plug positive numbers in, I'm only going to get positive numbers out, so the range is y is greater than or equal to 0. And the domain and range will change depending on what transformations happen to the graph. We're also going to look at the parent function of the cube root graph. So this would be the inverse of y equals x cubed. Here this is not going to have a restricted domain because I can plug whatever I want into the cube root function. It doesn't matter if it's positive or negative. When I pick some x values to graph this one, I'm going to pick perfect cubes. So we know 0, 1, and 8. And we can also do the negative, so maybe negative 1 and negative 8. So we know the cube root of 0 is 0, cube root of 1 is 1, cube root of 8 is 2, cube root of negative 1 is negative 1, and cube root of negative 8 is negative 2. So there's the graph of your cube root function. If you can remember the graph of x squared from chapter 5, looks something like this. So if you can imagine that being reflected over the line y equals x, this is the graph that you're going to get, the inverse of that function. When you have a cube root, you can plug whatever you want to it, no matter if it's positive or negative. So the domain here is going to be all real numbers, and same with the range. Any cube root function, even if it has transformations that occur to it, will always have a domain and a range of all real numbers. That will never change. So we have the square root and the cube root, and notice A, H, and K are happening in both of them. A, H, and K are the same transformations that we looked at with quadratics and absolute values last semester. A tells you whether your graph is going to stretch, compress, or reflect across the x-axis. Remember, if A is a whole number greater than 0, it's going to stretch. If it's between 0 and 1, it's going to compress, and then a negative a makes it reflect across the x-axis. Any a value that we have is going to affect our y values. That's going to be important when we're graphing the transformations of these things. H is the number inside the function, and H moves the graph left or right. And remember, this is the one that does the opposite of the sign. So if it's a positive number underneath, it's going to move to the left. If it's a negative number underneath, it's going to move to the right. And if we're moving left or right, that affects the x values. And then k is the number outside of the function, and that's going to move the function up or down. And if we're moving up or down, that again affects the y values. So anything that affects the y values changes the range, and the x values changes the domain. So we're going to have to keep that in mind when we're graphing square root functions. Those things will change the domain and the range. But again, the cube root will always be all real numbers. So if we look at these three examples, we just want to say what transformations are happening to the graph. So if you look at the first one, it's coming from the parent function, the square root of x. The only difference now is we have a negative in front. That's your a value. A negative a value is going to make your graph reflect across the x-axis. Here, the parent function is the cube root of x, and we have a 2 as the a value and a 4 as the h value. So this 2 is going to stretch the graph. We say stretch by a factor of 2. And then that 4, it's a negative, well, it's a positive 4, but it's negative coming from the function. So it's going to shift right 4 units. Last one's also coming from the parent function of a cube root, but now we're subtracting 5 on the outside of the function. So that means that I'm going to shift down 5 units. All right, so when we graph these, for every one, we're going to graph the parent function and the transformed function on the same coordinate plane so that you can see the difference between the two. We're also going to use the table of the original function to help us change the x and the y values to get new points to plot. So first of all, if we look at this function, it's multiplying the parent function square root of x by a 2 in front. So what that 2 is going to do is stretch the function. So we say stretch by a factor of 2. So let's start by graphing the parent function. That would be y equals the square root of x. If you can remember the t-chart we made at the beginning, we picked x values that were perfect squares, so 0, 1, 4, and 9. And we know those outputs are 0, 1, 2, and 3. We're going to be making this table a lot, so if you can remember those x and y values, that'll make it a little bit easier. We're actually going to use these values then in a second and multiply our y values by this factor of 2 because the 2 is affecting the y values. So there's your original. We're going to use this table to help us find the new graph. So since I'm multiplying my function by 2, I can actually go through and multiply all of my y values by 2. And if I do that, the x values have not been affected by that a value, but the y values have all been multiplied by 2. So there's my new points to plot for my transformed graph. So 0, 0 didn't change, but I stretched a little bit here, up to 2, up to 4, and up to 6. So we ended up with a little bit wider of a graph. Now let's also think about the domain and the range of this transformed function. This a value doesn't affect the x values, so that means the domain stays the same as the parent function. X is greater than or equal to 0. Even though the y values have been stretched a little bit, it still starts at 0, and we have every y value up until infinity after that. So the range actually isn't affected either. It stays as y is greater than or equal to 0. All right, let's try one with the cube root function. Again, we're going to graph the parent function and then use that table to find new values to graph the transform function. This negative in front is going to reflect your graph across the x-axis. So let's start with our original values. We picked -8, -1, 0, 1, and 8, because we know those are all perfect cubes. And these are my outputs. There's your parent function. The a value always affects the y values. So what I'm going to do is go through and multiply every y value by this -1, which is the coefficient there. So again, the a value is not affecting the x values at all, so those are all staying the same. And every x value is just going to change signs. So you can see how the parent function was flipped over the x-axis and it's been reflected. Even though we transformed it, the domain and the range of cube root never change, so it's still going to be all real numbers. All right, let's look at one that has more transformations than just a. So now I'm subtracting 3 in the function and I'm subtracting 1 outside of the function. Same as the last one, that -1 in front is going to reflect your graph across the x-axis. We have a -3 in the function. It's going to do the opposite of what you think. It's going to shift right 3 units. And then a -1 at the end is going to shift you down 1 unit. So always start with the parent function. The a and the k value are both affecting the y values, and the h value is affecting the x values. When you're transforming the table, you always want to do the a value first before you take care of the k value. So I'm going to go through and multiply all of my y values by -1 because that's what a is. This is affecting my x values, and since I'm shifting everything to the right, I'm going to add 3 to all of my x's. So let's see what we have so far. And my y's have just switched signs. I still have to shift this whole graph down 1 unit, and that's going to affect the y values. So now I need to go through and actually subtract 1 from all my y's. So I'll make one more table. So when you have an a value and a k value, you need to multiply by a first, then take care of the k value. So these are my new points that I'm going to plot. We've got negative 5, 1. Two, 0, 3, negative 1, 4, negative 2, and 11, negative 3 is a little bit off my graph. So as you can see, the parent function has been reflected across the x-axis. It has shifted to the right 3 units and then shifted down 1. Cube root, domain, and range never changes. So the domain is all real numbers and the range is still all real numbers. All right, let's just look at a couple and try to state the domain and range without actually graphing it. So on this one, we have 2 times the square root of x plus 1. This 2 in front is not going to affect the domain and the range, but the 1 inside is going to affect the domain. This is shifting it to the left 1 unit. So that means my domain is going to also shift to the left 1 unit. So instead of it being x is greater than or equal to 0, it's going to be greater than or equal to negative 1. Since I don't have a k value, I'm not adding or subtracting anything at the end, the range isn't affected. So it's the same as the parent function. No matter what you do to the cube root function, the domain and range don't change. So even though I've reflected that one, the domain and the range are still all real numbers. On this last one, we're adding 3 inside, which means we're shifting to the left 3 units. And we're subtracting 4 at the end, which means that we're shifting down 4 units. This one, shifting left 3 units affects the domain. Shifting down 4 units affects the range. So instead of my domain being x is greater than or equal to 0, it's greater than or equal to negative 3. And instead of the range being y is greater than or equal to 0, it's y is greater than or equal to negative 4. See how they directly affect the domain and the range.